Hello, I'm Ben Burgess. I'm one of the directors at William Hackett. We've been manufacturing lifting products in the UK since 1892. Today I'm going to give you a short overview of our subsea lever hoist, the SSL5QP. Firstly, what you'll notice that the key user interfaces are high-vis in terms of the colour to denote and attract attention to those areas. The second thing that you'll notice is it's very compact. This is very important when you're working subsea, reduce visibility, reduce space, etc. for ease of handling. You'll also notice here that the handle has a pommel on it and it's a soft rubber finish, so ideal for gripping, particularly when it's wet and with gloves, etc. So very good for the operator in terms of a point of interface. So this particular hoist, you'll see that it's very compact, very small, very light. This is a 1.6 ton lever hoist. It weighs only 7.4 kilograms at 1.5 meter height lift. That means its performance ratio is 216 to 1. It lifts 216 times its own body weight in terms of its working load limit. That is testament to the design and the quality of the materials used. So that said, moving on to some of the key functional attributes and benefits of the product today. As with most lever hoists, to raise and lower, you move the gear shift to the left and right. And you'll notice straight away that it's lifting and lowering only the load chain here. The brake is engaging. This has a 2% light load. So it exceeds the EN, ASME, NORSOC, Australian and South African standards in terms of that 2%. So as you see here, we're lowering here. I'm now going to engage what is typically with the gear shift in the vertical position, neutral. However, what you will notice here is as I pull on the load chain, it is not paying out. This requires a two-stage neutral operation, so a conscious step by the operator to pull the grip ring forward laterally so that the load chain can engage and the free-wheel and rigging mode can then be operated. So the second thing I want to go on to talk about is the dual action brake jabs. We all remember of the seat belts where they were fixed. We're now familiar with seat belts with an inertia brake, so when we pull or brake, the seat belt grabs and restrains you. But likewise, as soon as the tension is released, you can move within the boundaries of your seat belt. That is exactly the same as the principle here. That is important and was a key design feature, so that when the hoist is being operated perhaps 3, 6, 9 meters away, and the operative is pulling and paying out the load chain to rig a load, if the brake mechanism engages on all first generation hoists, the operator has to go all the way back to the grip ring to engage neutral again and to carry on rigging. This takes time, effort and adds risk to the procedure. With the William Hackett SSL5, you pull on the load chain. If there's a jerk in any way, shape or form, it engages the brake mechanism. To release that, you just release the potential and you can carry on rigging without having to go back to the unit. Let me demonstrate. So I am going to pull out the load chain here, engage the brake, I'm going to release the brake, and now I can carry on rigging without having to return to the grip. To engage the brake mechanism, simply hold the chain, twist the gear lever, and now the brake mechanism engages. Here we have the travelling end stop. It has the same factor of safety as the chain in working the limit. To engage it, it is lifted and placed underneath the body of the hoist. So should there be an issue with the brake mechanism, the travelling end stop will stop at the payout of the load. When the operator comes back to the hoist, he checks to make sure that there is still a gap between the travelling end stop and the body of the hoist. If that is the case, everything is good, and as is, the travelling end stop can be released and lifting can commence, always remembering to lift first before lower. So these are a number of the key features in terms of the exterior of the product, its functionality. But I want to leave you with one additional safety point. This is a quad haul lever hoist, a pole is an individual device that engages with the ratchet gear of the hoist to restrain the load and to lift the load. This is the world's only 4-pole, quad-pole lever hoist in the world. Its resilience to failure, we believe, gives it the safest brake mechanism in the world. It is tested to twice the endurance standards of all of the international standards. It is patented by William Hackett. So this is the William Hackett SSL5 QP lever hoist, specifically designed for the offshore and subsea marketplaces. So let me explain the quad pole system in a little bit more detail and to bring it to life.
Since the inception of manual hoists, the principle of reduction gears to gain mechanical advantage, with ratchet gears and poles to arrest rotation, have been used as the basis for their operation. Early lever hoists utilized a single pole assisted by a tensioning spring to halt rotation. Although functional, this configuration contained a real risk of a single-point catastrophic failure in the event of a simple spring fracture. A significant design advance was made through the introduction of twin poles. This negated the risk of single-point catastrophic failure, arguably making hoists twice as safe. Twin poles have since been considered standard in lever hoists, but this configuration has its own design flaw. When a lever hoist is used in a fine tolerance tensioning application, it is possible that the poles could be forced into an unstable location point with the ratchet gear. At William Hackett, we have been looking for ways to improve the safety of hoists. From our experience, poles and pole springs are frequently replaced spare parts, and hence we can deduce prone to wear or failure. In standard hoists, if the pole spring fails, pole engagement cannot be guaranteed and failure becomes probable. This led us to develop a solution that enhances this critical function and the safety of hoists based on the resilience to mechanical failure. Like many ingenious solutions, William Hackett's patented design is simple. This design incorporates 4 individual poles working as a pair on each pole stand. As the ratchet gear rotates, the gear teeth cause the poles to move and the profiled mating faces of the poles interact. This interaction causes the adjacent pole to engage with the next ratchet gear tooth. The design does not depend on a spring for its functionality, albeit the inclusion of a spring provides additional resilience. Thus, the holding of the load is controlled by 4 poles, making the hoist even safer to use. The new design also makes the hoist capable of finer adjustment thanks to the reduced distance between pole engagements. Each pole has fewer engagements with the ratchet gear as those within a twin pole hoist, thus increasing the service life of the hoist. This is the William Hackett SSL5 QP. Safe just became safer.